Okay, everybody, we're back. And this project just keeps getting more and more interesting as we go. First of all, I think I left off the last video that I applied voltage to this transformer and everything checks out good on it as far as this transformer is concerned. However, I went and printed out a spec sheet for the alignment and the measurements for this radio. And one of the first things I noticed was the highest voltage that we are looking in here is about 225 volts or so. So this, maybe 250 volts at the most, okay? When we look at the detector plate voltage, it's saying this reading will be obtained with a 300,000 ohm voltmeter as found in a blah 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 test set. Goes on, and it says the voltage at the opposite end of the resistor should read 250. So basically what they're saying, if I'm understanding this correctly, is when we look at the schematic, they're looking for a B plus voltage here of about 250 volts, which makes sense. These tubes really, that's what they're designed to run on, is around that. If you look at this, your plate voltage, for instance, on this, I believe this is the type 24 tube, you can see they want 250 volts, okay, and 180 volts is going to be your standard rating. 250 is going to be max. So really, you don't want this thing up over that. Now, as we measured, this is a center tapped 850 volt secondary, meaning that when you rectify this full wave, you're going to have about a 450 volt power supply, okay, roughly, okay, plus or minus. We don't want 450 volts. Now, I think that's what was going on here. Number one, all these tubes were damaged, and remember when I showed this type 45 tube to you, you can see all the little flakes. I don't know if you can see that in here, but you see the little sparkly flakes that are scattered inside the glass? I don't know if you can see that. Maybe you can pick it up sparkling. This tube's really had some heavy voltage on it, and I do believe that that's part of the problem, is that when they replaced this transformer, this was way too high of a voltage, and I think they tried to fix it by putting this choke coil in here, which probably has a higher resistance on it, DC resistance, probably got a lot of turns on it, to try to lower that down. But still, I would argue that this probably is still putting out way too much voltage. So, after all that confusion, I did a little bit of calculating, and allowing for the 30 milliamps of plate current on the 45 output tube, and having about 2.5 milliamps on each of the RF tubes and so forth, I'm figuring out somewhere around roughly 40, let's just figure 40 milliamps is all that B plus supply is going to see current-wise on it. And if I do the math and divide that down, I want to basically cut my 450 volt supply in half to 225. It came out right around between a 5.6 and 5.7K resistor, dissipating almost 9 watts of power, which is insane. So basically, I have ordered a 25 watt 5.6K resistor, among some other things. I did a parts order today for the ICO ST70 and some other projects and some things for work. I just had a bunch of parts that I needed for a bunch of different things, so I just placed one big order today. So what we're going to try to do to make this work is we're going to make up a little bracket out of some angle iron to be able to mount this securely in this way, okay, in the chassis. All right. and kind of come up here on you. So we want to go in like this and mount it underneath this in like so. Wire this whole bundle in, and that's kind of the way it was when I found it, but I'm just going to try to mount it a little more securely. Then we are going to remove this mess in here, and on this back we're going to use this whole chassis as a heat sink, and we're going to mount our chassis mount 25 watt resistor right on here to drop our voltage to where it needs to be. Now this is going to be a very inefficient power supply because so much power is going to be wasted just by that resistor. You know, you're pretty limited on your choices here. You can either do that, or we can try to find a transformer, but finding one that's going to have these windings on it, have a 5 volt and two 2.5 volt windings, wow, that's going to be really difficult. I mean, probably there are some out there. I could probably do some digging. It's going to be difficult, and quite honestly, probably going to be cost prohibitive price wise. We got to watch the budget. You know, I don't mind putting $10 worth of capacitors and $10 worth of resistors in this thing, you know, to get it going. The customer really would like to see this radio play again. But if we have to get into all of this stuff, you know, with the transformer, it's just, you're getting yourself priced out of the market. So that's what we're going to try to do. You can see they made an attempt at this, and you can see how hot, I mean, it's just burned the paint right off of this resistor. It's all charred and discolored. But I think this resistor was actually an attempt to step that voltage down along with that choke coil, which probably has a higher DC resistance, I would say, because you can get choke coils with higher DC resistance on them. And if you look, you can see we got about a 4K resistor in there, okay? So I calculated 5.6K. So you figure if this is a 4K resistor, 4.7, whatever it was, 4K, and then you add another maybe, you know, 500 ohms to 1K in this coil, they were doing exactly what I'm thinking about. And that is, you know, dropping this all down through a dropping resistor. The only thing is we're going to try to do it a little better so that it'll last. Again, it'll waste a lot of energy, but this radio isn't really about being green or being energy efficient. It's about hearing what the old technology sounded like in the old days. So that's where we're at with this. And as soon as I get some components and get some things together to be able to show you guys, I'll come back here, and maybe we'll be able to put Humpty Dumpty together again after all. All right, more to come. All right, just for your information real quick, I'm looking at the choke coil down here, and you can see I'm connected to it. And it's a 1.2K coil. So if we take 1.2K plus the 4K, it's about, well, it's actually almost 1.3K. So we got about 5.3K, which is right in line of where I was calculating we need to be for voltage drop. So they did it right when they did it. Just kind of the way it was put in there. That resistor is a little bit too small for the dissipation that it's going to have and so forth. But I think we're on the right track. So just a little update. Okay, so I've gone through and checked all these coils, and from what I can see, they seem to be all right, with the exception of this one may have one disconnected wire here that I'm going to have to fix. But all the other ones seem to test out. Now, the one thing I noticed that was a little bit strange was, well, I guess it's not strange. This coil's different. According to the schematic, this position would be your first RF coil. And if you look, the first RF coil has a little bit different style of, instead of being the coil being on top, it's down on the bottom. And if I can just move this towards you here, you can see where that coil is actually right down inside there. It is down in the bottom. And again, they all seem to be reading okay from what I can see. And I think they cleaned up pretty nicely. Again, you have to be very, very careful with this enamel. This old enamel tends to get dry and brittle and flake off, and then the coils will short. Looking at this, that hasn't happened yet, but I may take a coating of nail polish or some really fast drying lacquer and put a really thin coat. But again, you can't put too much on these coils or it will affect the frequency of the coils, so we have to be very careful. So anyhow, everything looks good so far. I replaced those crunchy, crusty, really bad wires with some original cloth covered wire that I had. And if you take a look, here's what I did. Even though this is old cloth covered wire, phone ringing, be right back. Alright, I'm back. So anyways, I basically took some original cloth covered wire. I don't trust cloth covered wire that's old. So what I do is I take some of this clear heat shrink and I just kind of pull it over the wire and shrink it down, and that almost makes it look like the wax coating that they put on this cloth covered wire, so it kind of looks like original. So I'm going to finish up these coils. You can see the little capacitors. These actual little straps that go around here actually have a little tiny piece of mica in them. Very delicate. We have to be extremely careful with them. And by adjusting that screw, you're tightening and loosening the two contacts that sandwich that mica in there, and that changes the capacitance. And that represents these adjusters right here. See them? 1, 2, 3. And those are, and then right here, 4. So you have your 4 trimmers, and those are what's set up. Basically what they are is they trim up the imperfections in these 4 ganged capacitors under here. Okay, so you see your capacitor gang right there, and they're not going to track totally perfectly. They're not going to have the perfect capacitance, so these allow you to trim them up so you don't get that beat frequency squeal that I was talking about. That's what you do to get rid of it. And you'll find out when we go to do the alignment of this, if we get this to a point where it works, you'll hear the effects of having it in line and out of line alignment. So should be a pretty interesting thing to see. So anyways, that's where we are with this right now. I'm going to start, I'm going to maybe finish cleaning up these coils very, very gently. I'm not going to mess with them too much more. And then I'm going to put the covers on to protect them, and then start maybe doing a little bit of de-rusting and a little bit of cleaning on this chassis. All right. Okay, another example of why you have to watch my videos all the way through. When you watch my videos, you just never know what you're going to hear. Anyhow, I did make a mistake. Aren't you amazed at that? Anyways, if we look down here, we have one other component that I didn't count into my calculations when I did this, and that is the field coil. That field coil will drop the DC to some degree. So actually, this transformer may not be as far off as I had anticipated. So we have to take this into consideration as well when we calculate our dropping resistor to make sure. So maybe this is the right voltage. We don't know yet. But I just wanted to bring that correction in to you. And probably what I see is sometimes when I make these mistakes and then I come back later in the video and correct them, people hurry up and they type in right away that they caught the mistake there, and then as they watch on they realize I caught it later too. But anyhow, just wanted to update you on that and see exactly. The other thing is these 2 resistors here, I'm wondering if they're contained inside this little can here. So we may try to pop this open as well and see what's inside. It is soldered, but we might be able to get it opened up and look inside. Stay tuned. Alright, so all the coils are now good. I am 100% sure they are good. At least I'm 80% sure that I'm 100% sure. Anyways, this wire, there is a wire in these coils that runs from this tap up to this tap. It runs through this eyelet, down through the inside, and comes out here. That wire was broken on this particular coil. So basically what I did was I took a little piece of magnet wire, like this, very thin stuff. I ran it down through the eyelet, as you can see, right there. You can see it right there. And it comes through this eyelet, and then it goes down. It comes out here, right there. You can just see where I'm pointing to it. And now it's fixed. So now all the coils are good. Part of me wants to put a thin coat of shellac over these coils to protect them, and then part of me doesn't want to, because that's in and of itself can cause the enamel to go bad. Right now the enamel seems to be pretty sturdy on here. I have a really soft bristle brush, as you can see here, very soft, and if I brush it, you can see that it's still pretty good. It's got a little bit of dust on it, and to brush the dust off, but it's not doing anything at all to the enamel. So part of me thinks we should just leave sleeping dogs lie. I think this should be just fine. As long as nothing gets in there and touches those coils, I think they'll be okay. This wire at the top is a real thin cloth covered. I don't know that it's Litz wire. Litz wire is a special wire that has strands in it. It's designed to like cancel out RF kind of. It's a special kind of wire that they use in antennas and things. It has the cloth coating of Litz wire, but it looks like it's only a single strand, so I'm not sure about that. But anyhow, these little wooden bobbins up here are just held in by these two little nails, one on either side. Very delicate, but they're all good. They're all in good shape. I am not going to mess with them. So I'm going to put the covers on this while I'm ahead and just move on. Okay, got a little bit of de-rusting done and got the covers back onto these. Got the clips put back on. Look how nice those cleaned up, just like new. There was a little bit of deeper rust, but it's not too bad. It cleaned up pretty good. I didn't do a complete, soak it with navel jelly or anything. The owner can do that if he wants. And I just put a thin coat of oil on the metal to just preserve it for right now. So anyhow, we're done with that part, and I've moved on to the bottom here. Let's flip this around the other way. And let's bring you down here a little bit. So if you look down in here, you'll probably see it better than I can with my bad eyes. But if you look right in there, let me see if it'll zoom in closer without going all foggy on me. I don't know if you can see that or not, but this is the volume potentiometer, and you can see me moving it. Right there it sticks, and it'll kind of clicks over that little spot. The reason it's clicking there is because there's actually a teeny tiny little break in the pot winding there. It's a wire wound pot, and these wire wounds, if you remember from my ICO video for the ICO 950, had the same issue where one of the teeny tiny little windings, and I don't know if you can see that or not, but one of the little windings right here is broken. You can see it kind of moving around there. It's bad, and when those go bad, you really can't fix them. Now, normally that wouldn't be a bad issue. If you look on the front, the pot is actually your standard run-of-the-mill mount. It's a short knob. So this would actually be one of the easier ones to do. The problem is, when we look at the value of that pot, it is a really odd value. It's actually a 3K potentiometer, 3 kilo ohms, which 3,000 ohms is not a very common value for a potentiometer. So, and again, I don't know how many watts it needs to be, because those wire wounds, I mean, they could handle probably about 3 or 4 watts, but I don't know if that's really necessary on this particular design. But what I will say is that's definitely a bad pot, so I'm going to have to come up with something for that. Not sure what. Maybe I can put a 5K in there and shunt a resistor across it. I'm not sure, but again, I don't know what that's going to do. I don't know. We'll see. Anyways, that's kind of where we are right now with this, and I am just going to wait and see, come up with some idea for that. Strangely enough, this orange resistor is supposed to be 30K, and it's reading right at 30K, like 29.7K. So as crusty as this thing is, it's still good. This resistor right here, though, is a wire round, which means it's a higher wattage one. It's 300 ohm, and it is definitely off. When I read it, I'm getting about 520 ohms on my 300 ohm resistor, so it's definitely going to have to go. And that's par for the course. It's a power resistor. You can see the little windings on it. So that'll have to get replaced. This was actually like a little tag board that was mounted onto the original transformer. The original transformer had these all the way around, like in a U shape, and had terminals all around it, which, with that transformer being gone, that's no longer there, so these wires are going to have to be all redone. But these ones down here seem to all be in pretty good condition yet, so I'm going to probably leave them as is. As long as they don't move too much, I think they're going to be fine. So definitely have to get rid of these old paper capacitors. I did do a little bit of online research. I found one other person on a forum that tried to do did a restore of one of these. I don't know if he was successful in the end or not, because I didn't see how, I didn't hear any more comments. But definitely this capacitor, number one, it is not an electrolytic. Apparently at the time this was being made, electrolytics were very hard to come by, very expensive. So this is a paper capacitor. And even though there's 16.25 microfarads, there's actually multiple capacitors in this. And basically all of the caps that were in this thing have been bypassed with something else. So when you look underneath here, turn this around, you can see they have one here, they have one here, and then they had that other bigger one that was in there. These capacitors are all paper capacitors. They're all going to have to go. They're shot. They're no good. These resistors, we're going to measure through them and see how many of them are still good. We'll replace them if need be. But really, there's very few components in this radio if you look. The main thing is just cleaning up the wiring and things, and getting it in there the right way, getting everything tied back up and insulated properly and safe, and to deal with this pot. Now, luckily, this pot, or rheostat, whatever you want to call it, it's good. It's perfect. It reads the right resistance, and it tracks properly, so that's still good. But you can see it's been kind of taken out of the circuit. There should be a capacitor on there, and this is the tone pot. If it were 3K, I would just swap it out and not have a tone pot. But this is a 10K pot, so wouldn't you know, the one that's good is the one that's a common value. Murphy's Law. Anyhow, I'm going to get to checking some of these things out, start cleaning some of this up, come up with a solution for this pot, and then we'll be back. Okay, this speaker is really roached, as you can see. I'm just not going to touch it, I don't want it to tear, but I have the signal generator connected to it, and listen. It does make sound, so it does have a good voice coil, but it definitely needs the surround replaced, if nothing else. So, but the output transformer is good, and the voice coil is good, and the field coil is good. So it's a repairable speaker for sure, but it's definitely going to need some work, and until then it's going to sound pretty bad, but it is going to work. Alright, the speaker needs a new surround, but it does work. I put voltage into the field coil, and I put a signal into the output transformer, and I get sound, and the sound increases as I increase voltage on the field coil. So it works. The spider is good. It's got one of those old-fashioned brass spring type spiders. The voice coil is good. The cone is not torn at all, but it is very delicate. I don't even want to touch it. The surround is completely shot. It is it's dried out till it's completely stiff, and it's no good anymore. It's shrunk. It was probably a leather surround. It looks like leather, and that's pretty normal. They used to do that. So that needs meticulously removed and replaced. So I can leave that for the owner to do. But the speaker will make sound at least so they can hear it for now. So I'm going to put it back in the case before it gets damaged. But it's good. Okay, so this is where we're going to leave part 2 off here and finish up. All of these resistors are good. They're all within tolerance. This one's about the furthest one out, and it's still, I mean, if these are plus or minus 20%, they're well within. Most of them were within 10%. So I don't really see a reason to replace these. I kind of think they're cool looking, and I think I'm going to leave them as they are. These capacitors are very modern, so they obviously don't need replaced, but we may reattach them. The ones that are going to need replaced are these 3 foil capacitors. You can see them. And they're not wax covered either. They're just exposed to the outside world, so they're going to need replaced. They're going to be a little more difficult to replace, but I'm sure I can get at them and get them replaced in there. So where we're going to leave off is we need some foil capacitors replaced. We need to come up with some sort of substitute for this pot, which I think we can do. And the big challenge, is $64,000 question, is getting this big transformer remounted and getting it to put out the correct B+ voltage so it doesn't damage the tubes. And last but not least is to get some tubes in there, and I don't know if I have all of the tubes that I need. We may need to purchase some. I don't know if I think the customer wants to go ahead and do that. So we may have to wait to order those before we can actually put power to this thing. But that aside, I think we may be able to get this thing working. We'll see. But anyhow, I'm going to shut this video down here and get it posted. And when we come back, we'll be working on the capacitors and the wiring in here and doing something with the transformer. So, hope you like this. Give us a thumbs up if you do. And we'll be back. Thanks a lot, guys.